Well, good morning, everybody. Welcome to day 2 of AnDevCon. Yesterday, you guys had a lot of technical sessions. We heard some great keynotes from Aparna and from Jeff. This morning, you've already started with some technical sessions. So I hope you're learning a lot about how to improve your products, how to grow your business, and we're going to continue. Our goal is to continue to do that for you today. My name is Mike Roberts, and I lead the developer program at Qualcomm. You know, as a newly minted EE, my first job was programming C, and I quickly learned that software was not going to be my wheelhouse, nor was sitting behind a Sun Spark station. See, it was hardware where my true passion drove me. And so it's really exciting for me to think about hardware as somewhat garnering the spotlight again. So we're going to talk about hardware and software today as we take this journey into the Internet of Things. Now, it feels like there's an IoT conference just about every week. It's billed as the next big space, the next land of opportunity, the next thing to happen after the mobile application space. Well, research tells us that if you look to your left and if you look to your right, one of those developers is currently involved in IoT. There's a natural evolution from mobile application developer to an IoT developer. There's a convergence of skill sets happening. Today, we're going to talk about some of the barriers of entry we've had, how those are lowering, and how now is the right time to get into this space. Now, there have been 4 main challenges in this space. The first, immature platforms. And this isn't different than any other brand new ecosystem. The IoT landscape was fragmented, had a variety of standards, wide range of proprietary solutions, and there was really nothing for you as developers to scale upon. And frankly, as we look at IoT, when things stop talking to each other, the entire value proposition kind of falls apart. So with dozens of competing IoT standards, the best you could do was build a great product in isolation in hopes that that maybe worked with some competing or adjacent solutions. Well, now we're starting to see signs of convergence happening. We're starting to see winners surface. At Qualcomm, we have always been focused on making sure that our technology works across a wide array of software platforms and ecosystems. Many years ago, we started with AllJoyn. We've recently joined the board of Thread. And we're going to continue to look at those platforms that rise to the top to ensure that our technology can work on it. Second, lack of hardware development knowledge. Now, when I first started my hardware job, this was right after my software foray of writing C, I used to joke that the equipment on my bench was worth significantly more than the townhouse I had just bought. So it was a very honed skill set that I needed to learn. And it was a high barrier to get in for anyone who didn't know hardware as an extensive background. Well, now the availability of new tool sets is making hardware much more approachable to those that don't have in-depth knowledge. And we're going to talk about some of those tool sets later in the presentation. The third area, lack of software development knowledge. So there was very little crossover between hardware and software. If I was a hardware engineer, I didn't know much about software. That's frankly where I was. But today, there is a huge and ever-growing database of code samples, of training resources, of working examples, so that you don't need to write code from scratch anymore. And the fourth space, which is probably the largest. So when you think about hardware, you think about massive capital up front. You think of risk and inventory management on the back end. Well, now as IoT matures, costs associated with hardware development are decreasing, and there's reduced friction as you bring your product to market. I'll give you some examples. So 3D printing is a fantastic rapid prototyping tool, available today on the consumer market for less than $500. When you think about production and logistics, It's becoming easier to manufacture at lower volumes. We're seeing specialty supply chain firms come up to speed that will actually help you. And they're rising in terms of this increasing developer demand in this space. So I was in Shenzhen 6 or 7 weeks ago for the Maker Faire. Has anybody here been to a Maker Faire? All right, a few people, cool. There's going to be one in New York, the World Maker Faire at the end of September. We're going to be there. I hope you guys are there as well. But the fascinating thing about Shenzhen, so here's a city where the DNA is about rapid prototyping and mass production. And now you have people coming in. You have hardware developers, inventors, makers, coming into this space, and I can take my product from concept to viable prototype in 3 months. And then I can go down the street and get mass production on that product and scale it to whatever volumes I need. Now, if you're thinking to yourself, wow, maybe I'm behind the curve in this IoT thing, I want you to take comfort in a statistic. 75% of IoT developers have been working in this space less than 2 years. This is early days. And there's a migration of seasoned developers, but there's also an entirely new generation of engineers rising to meet this challenge. So while development has become more frictionless, we still haven't answered an important question. Why do you want to get into this space? Why should you spend your time and energy in IoT? Well, market research will throw a ton of different stats at you. There's a stat for everything in IoT, but I want you to focus on just one. And to provide you some perspective, this year, it's expected that there's going to be around 1.5 billion 3G, 4G devices shipped into market. 2 years ago, that number was 1 billion. Well, that's pretty good growth. But now let's take a look at IoT. The projection is on the low end, 25 billion connected devices. On the high end, 50 billion connected devices. For developers, more connections means a huge opportunity for you, and I'll tell you why. The more devices that are intelligently connected require user experiences to simplify the inherent complexity that comes with IoT. So if you're an early adopter of IoT today, any device you buy is most likely a siloed experience. Essentially, your device acts like a controller. But for IoT to really take off, we need to humanize the experience. We need to integrate technologies like machine learning. And while it's cool to be able to open your garage door, close your garage door, cool to turn on a light or turn off a light, we need to be able to have a user come home, the garage door opens, the kitchen light turns on, and the alarm turns off. There are so many use cases, so many ways for us to impact millions of people's lives. As IoT matures, the experiences you create, I truly believe, will permeate people's lives as much as the smartphone has in the past few years. And most importantly for you today, you will have the tools to work with easily create connected experiences without needing to come up a whole new learning curve. So what's the process to building an IoT app? Well, the good news is that a lot of the infrastructure is in place, so a lot of the code has already been written for you. So first you need to think about your project. Do I want to build an app? Do I want to build a thing? Or do I want to build both? But I want you to remember something really important. It is not the data alone that makes IoT valuable. It is making that data valuable to the end user. You are at the top of the stack here for a reason. And while all these are really important components of the ecosystem, it is ultimately the user experience that will make or break this segment. If we're honest with each other, we're already inundated with just way too much data. So it'll be the responsibility of the developer community to show the value in having a connection to so many things in our daily lives. Now let's say you want to build a thing, a physical object. To some of you, that may be a little bit scary. Perhaps you have never understood the color coding of resistors. Perhaps the idea of measuring voltage in amps is just not up your alley. Well, the good news is that the open hardware movement is alive and well today. And it poses a really important question, probably the most important question of the morning. Can hardware be developed and iterated at software speed? One more time. Can hardware be developed and iterated at software speed? I think that's our challenge. You see, the Internet of Things is part of a much larger movement of making the physical environment accessible to people in the same way that the Internet has been made accessible over the last 20 years. So what does open hardware mean for a software developer? Well, first, moving into hardware shouldn't be intimidating. Hardware development is becoming agile and is built with ease of use in mind. Massive communities are forming online, so now you're going to have your peers to help you on these popular hardware platforms. Additionally, on the software side, that's opened up a gateway to hardware, because now it's possible to program embedded systems with high-level programming languages like Python and JavaScript. This means the number of people who can approach hardware has increased dramatically to include both beginners as well as software developers who have little or no hardware experience. So now let's talk a little bit about hardware. After all, IoT is about connecting billions of things, of physical objects. And while those are going to vary greatly in shape, in size, and functionality, at Qualcomm, we believe we have the right requirements in place. You see, Qualcomm was built on mobile. Every employee, every engineer, this is how we think. It's in the forefront of our mind. And when you build for mobile, you deal with certain design constraints every day. You have to build for low power, but you also have to build for high performance. You have to build with a very tight thermal envelope in mind. And you have to be able to execute code in a very small amount of memory. It sounds a lot like what we're going to need for IoT. Now consider the innovation that's happened in the mobile market over the past 7 to 8 years. In 2008, we helped launch the first Android device on a very simple ARM processor with fairly low uplink and downlink speeds. Well, numerous chipset iterations and over 1 billion Qualcomm-enabled Android devices later, the key technology areas have grown 3 to over 100 times. I mean, think about your first smartphone. Think about the web browsing experience, the graphics capabilities, the display resolution. You know, it wasn't long ago that all seemed in the realm of science fiction. So while each vector of technology has increased, the integration of these technologies actually decreased in footprint. So if you think about that device in your hand today, that very small device, although some of them are getting quite big with the larger displays, but the battery energy in that device is 20 to 30 kilojoules. That's enough to lift a person like me off the ground 10 stories. The processing capability is the same as a supercomputer in the early 90s. The graphics capability is console quality. And while we used to carry around a camera and a camcorder and a GPS, that's now all integrated in your hand. So with all these integrated technologies prevalent in the most widely adopted platform in the world, we now have the power to harness this for different use cases in IoT. Now, we think of 2 main categories for IoT devices. The first is smart devices. So these are much richer in terms of power and performance. They have much higher sensor capability, and they are using their own device analytics. The second is IP connected. These are much simpler products like light switches, like thermostats. And one of their main jobs is to get data into the cloud. As you look at each of these categories, you're going to see the requirements mimic very much what happens in mobile. And we have development boards for each of these categories. These boards allow you to take advantage of the billions, tens of billions of dollars that Qualcomm has put into mobile. And you harness those for your products, for your innovations. Gartner put out a report a few months ago that said half of all products in IoT will come from companies less than 3 years old. Essentially, that means the people in the room, you guys are going to be the innovators of the IoT space. Now, I want to provide a bit more detail on each of these boards. First, the 410C. At the heart of the 410C is the Snapdragon 410. Now, here's a processor that's been shipped in tens of millions of commercial mobile products. And we're now offering it to the developer community. This is the first time that we've done this, especially at a price point this low. Additionally, in support of open hardware, we're Arduino compliant. And we're also standardized on the 96 boards ARM open platform specification. We're also providing a breadth of high-level OS options. Windows, including IoT 10 Core, Linux, and of course, Android. Now here's a closer look at the board itself. As an engineer, I like to look under the hood, and I thought you guys might as well. Now we built this board with the necessary horsepower to power your most ambitious products. It has a quad-core 64-bit ARM A53s. It has our own customized GPU. It has generous onboard memory with 8 GB of flash, 1 GB of RAM, and microSD for expansion. We have a comprehensive suite of wireless services, including Wi-Fi, Bluetooth, and GPS. And we have ample connectors for you, HDMI and a couple of USBs, as well as high and low speed expansion connectors. All this in a board smaller than a playing card, available today for $75. To support IP-connected devices, the GT202 is our current development platform. It contains our low-power Wi-Fi solution. And it's also Arduino compliant. So you can now marry this with a microcontroller and run a real-time operating system. It also is pre-installed with AllJoyn. And it's also available to the developer community for $18. So what's the next step? How do we get to building a thing? Well, the first step is to take some of the boards that we just talked about. The second is I'm going to have to add sensors and some other accessories to get the physical world into my thing. Then you can access your data via the platform APIs. Deployment and device management are usually handled with the platform's ingestion layer. And now you can iterate and eventually build a viable prototype. Now, as we talk about connecting things, I want us to remember the whole is so much greater than the parts. Now, there's an equation on this slide for a reason, and I want to show you guys some examples and experiences that could come after this equal sign. So first, here's an interesting product. It's a smart egg tray. It tells you how many eggs you have, if you're running low. Actually, it'll even tell you if some of the eggs are bad. Kind of interesting. But what if we connected that to an automated grocery list? What if we connected that to a service that delivered eggs to our house when we were running low? We already see Amazon getting into this space, doing this with different products with their dash button. Now here's a smart piggy bank. And while you and I don't really use piggy banks anymore, this could be a really interesting learning tool for our kids, teaching them about money, savings, the value of $1. And it even comes with some Pavlovian conditioning in that every time you put in a quarter, the nose lights up. So it's kind of fun. Now today, our light bulbs are relegated to on and off, and if you're fancy, maybe a dimmer switch. Well, LifeX is a partner of Qualcomm, and they've created a Wi-Fi-enabled multicolor LED light bulb. It's a really cool experience. We have one at our booth if you want to see it. But imagine having the power of connected lighting in your application. What environment would you create? You could sync it to music. You could make the lights flash if the refrigerator door is left open. you could gently bring up the lights in the morning when your alarm goes off. Or conversely, you could flash the lights red when the alarm system goes off. You see, it's connecting all the things together that make the experience valuable. Now, given HVAC accounts for over 50% of our electric bills, it's really no surprise that Nest has forced every traditional thermostat maker to make a connected device. And I have one. I'm sure many people have them out there. If we had one in our hands right now, we'd actually heat up the room since it's freezing in here. But if I lived in the desert, it's really hot during the day. It's cool at night. Now, my connected devices should know, turn on the air conditioner at a certain part of the day, turn it off at another part of the day, maybe turn on fans in some room. And if the sun is blaring in, maybe lower those shades. Last example. So 2 years ago, I moved to San Diego to work for Qualcomm from Chicago. And Chicago has this awesome freshwater reservoir called Lake Michigan. And so really the only issue you had with your water bill was how expensive did you want it to be. Things are a little different in California. We can only water 2 times a week, only so many times per zone. But when I moved into my house, those restrictions weren't in place. And the previous owners had it on every single day, 12 minutes per zone. My lawn looked great, my garden looked great, water bill didn't look so great. But what if I had real-time soil moisture sensors at different parts of my yard? And it told the irrigation system how long to water and how much to water. What is that worth to a consumer? To save them valuable dollars on their water bills and also be able to save one of the most valuable resources we have, which is water. The underlying lesson of all these examples is that while isolated IoT experiences may become a novelty, integrated experiences will become a necessity. So now you have a viable prototype. You've gone from 0 to 1. Congratulations. Probably one of the hardest parts. But you still are not in production yet. So what are some things you need to consider? Well, the good news is that you have help. If you Google Hardware Accelerator Boston, you'll find a great organization right here. But you have these hardware accelerators, these hardware incubators all over the country. New York, Denver, Bay Area, San Diego. And they'll bring you in, they'll help you. They have equipment there. Some of them have engineers on staff. They'll help you get to viable prototype. And then many of them have manufacturing partners. So in San Diego, they'll connect you with the manufacturing ecosystem down in Tianjin. Many of them connect you with people in Shenzhen. And Qualcomm, we want to help you too. We have hardware and software tools to help you through the development process. We have a short video here to show you a couple of the ways that we're able to help you.
Things we use every day are connecting more than ever, improving lives and presenting new opportunities for innovation. For some developers, creating within the emerging Internet of Things can be overwhelming. With so much possibility, what resources can you use to take on this maze of new challenges? Qualcomm Developer Network, an online community with tools and support to guide you as you navigate the IoT frontier. Utilizing forums, blogs, and an array of hardware and software solutions, you have a clear path to follow. A future of connected things, ideas, and services are possible with the help of Qualcomm Developer Network. What will you invent?
So at Qualcomm Developer Network, our job is to serve you, the developer community. Our job is to help you make fantastic products in both the hardware and the software spaces. Now, we had a working session yesterday on Fort NC. We have another one today at 12:45. I invite you to come get some hands-on training. I invite you to our booth where we also have the GT202 Wi-Fi board and a lot of the software tools that can also help you. Tell us what you need. What are your biggest hurdles and how can we help? All of us at Qualcomm are really excited to take this journey with you into the Internet of Things. Thank you.